Hi everyone, and good day. Thank you for attending today's educational session. My name is Ron Velasco from International Trade Council. Before we start, let me do a quick housekeeping. Can you please type in yes on the chat box if you can hear me, if the audio is clear? All right, thank you. And you can also see the PowerPoint presentation. All right, perfect. And just a quick reminder, um, this webinar is for 1 hour. If you have any questions, you can type in your questions either on the chat box or in the Q&A tab of this platform, and then we will answer, or the speaker will answer the questions after the presentation. So for today's educational session, we have Imagine and Implement 3D Printing. The webinar explores 3D printing key points from industrial perspectives, needs and opportunities and challenges, needs for systematic thinking and new competences, and future products. Our speaker for today's educational session is Pekka Ketola, CEO of 3D Step Oil. So without any further ado, Pekka, you can start the presentation.
Thank you, and it's my pleasure to meet you today. I noticed there are people from almost all continents, and this is extraordinary event, I think, for us all. So welcome. In this webinar, I will go through some background information about me and my company very briefly, but the main points come later. Where is the industrial 3D printing going on at the moment? What kind of challenges we have related to the topic that we have today, imagine and implement? What are the opportunities? And most interesting, what products and businesses we will have in the future? So welcome to this journey of insights, I hope. My background is in Nokia innovation management and product development. I was there for 17 years, starting, maybe some of you remind the first smartphone, Nokia Communicator. That was my first product ever that I joined, and from there on I was dealing with new technologies, new user needs, new business models globally, and also from technology point of view, I was hunting for new technologies and bringing those into products for quite a long time. During my Nokia time, I also did my dissertation, and I was studying user-centered development in the context of very complex product development. You can find my dissertation online and download it if you are interested in that. Currently, I'm running actually 3 companies. One is the 3D Step for industrial 3D printing, and this is the topic for today. But because I'm innovator by heart and entrepreneur by heart, my other companies are dealing with electric vehicles in scooter mobility, and then also strategic innovation planning for different types of private organizations in Idea Scout company. So the person you are hearing right now, I'm an innovator. I'm not engineer. I maybe think a little different ways than typical engineers in this field, in this 3D printing field do. But I hope I can give you some new ideas and some guidelines for your journey forward with 3D printing. Feel free to connect with me in LinkedIn or send directly email so we can continue dialogue later on. Few words about my company. 3D Step was founded 2016 in Finland, and the background is that even 10 years ago we started to look at industrial 3D printing, and in particularly metal 3D printing as a huge opportunity for different industries. and we started to educate companies and organizations how they could use 3D printing. And slowly this thing took off in Finland, and then later on in Scandinavia also. 2016 we started our own business. We wanted that somebody starts metal printing business in Finland, but actually nobody did, so we had to do it in our own. So we started from the very scratch with very limited knowledge on the area, but now we have been working since that, and we are one of the leading service providers in the Scandinavia. We have two main lines of operations in our company, and it's also in the motto of this of the title of this presentation. Imagine. We do innovation services for the different organizations, and this means finding out what are the ways how any organization, company can make value with 3D printing. We educate, we coach, we find ways how the different organizations go into 3D printing or build better value with that. So it's very rich types of services we provide for this innovation. The practical side is implement. We provide metal additive manufacturing as a serial production or single product production. Polymers, we have different technologies, industrial technologies in-house, and we can provide even very large series of products to different industries. The segments that we are working on, they vary from medical to machinery and art and anything you can imagine. And in this presentation, you will see some examples of our work. So 3D step is about imagine and implement 3D printing. And now let's start. Here comes a short video. We are talking about what is the state of the industrial 3D printing. And this short video that you will now see shows how one 3D printing that we have in-house makes products. And then I will explain a little bit after the video. It comes now. Those of you who are familiar with the home printing or office printing are typically thinking about this FDM or kind of filament printing or some other ways of kind of simple printing. But what you saw in the video is a serial printing, which is powder-based printing. And this powder-based printing is the key technology area in metal printing and polymer printing. And I would say that all big industries use exactly these technologies when they do their production. These technologies are used in as well as in car manufacturing, medical applications, aviation, optoelectronics, robotics, and so on. So it's very well spread thing. But the video simply showed what it looks like when the printing happens. Now, when we look closer on this area, let's first look on the kind of size and some themes on the applications. So we are looking at the current state of industrial 3D printing. Today we have technologies that can print extremely small products. On the left-hand side, you can see products that have like 1 millimeter or 2 millimeter size, and they are perfectly produced and can be produced as a massive volume for different industries. These extremely small products are typically related to electronics, medical, or some other field where the size or kind of fitting in together a lot of small components is about the business. On the right hand side, where you see this SLM, it shows that we can do also very big products with different printing technologies. These powder bed technologies can go to like 1 cubic meter at the moment. But then when we go to robotic 3D printing, we can go several meters or even buildings as a 3D printed products. So now the kind of scale that we have, it goes from less than 1 millimeter to tens of meters. And within this scale, we have lots of different technologies. I think there are tens or hundreds even different technologies. In the middle, you can see this sneaker. And when you go to a sports equipment store in your city, you can probably find these sneakers which have 3D printed insole or some element there. And that means that 3D printing is in big scale in consumer products as well. And typically these can be very personalized products. You can order personalized sneakers online or simply take the best that you think fits with you. And on the kind of top middle picture, there's one example of big volume consumer product printing with certain technology. Um, the point of this picture or this slide is actually to show that we have a huge variety in sizes, huge variety in applications, and only the imagination today is the limit on these areas. When we look at the technologies and prices, don't worry, I'm not going to offer you whole list of technologies here. But the main thing is that now when the technologies develop, and for example, we add more lasers in the metal printing machines, like 12 lasers in one machine, the serial production gets very affordable. And if you think that 3D printing is expensive or that it has been expensive in the past, that is not the truth anymore. Because technologies are developing and machines are getting more powerful, you will really see that the prices are going down in quite nice speed. One reason for that is that there are many global manufacturers and material developers that are competing. There are big names, and even bigger names are now buying these smaller players, and which gives them more volume to develop these technologies. And if you look forward, what will happen? The prices will keep going down. The machines will keep getting more powerful, getting more features. This is quite typical technology evolution, and there is no reason why that shouldn't continue. So, top line, prices are getting lower all the time with 3D printing. Then we look at materials. Most typical question to us is what materials are available? And this is a very difficult question to answer in a short way. We can use in 3D printing all kinds of, not all kinds of, but very big number of different metals like aluminum, steels, titanium, and others. Even bigger variety of polymer materials, i.e. plastics. Composites are getting more and more available and popular now. Then there are biocomposites, so circular economy materials in a way. Biomaterials for medical care are being developed and tried out, but these biomaterials are not in a kind of patient treatment work very publicly yet, but there are many research teams everywhere looking at this bioprinting and biomaterials, i.e. living cells. Concrete for building houses and big constructions with robots. Concrete materials are being developed and available. Increasing use of recycled materials, especially polymer materials. And this is actually very interesting business, this use of recycled materials in 3D printing. Food 3D printing, you will see an example of that. That is also kind of very hot topic in a couple of places, but there are lots of pilots and trials going on with different food types as a 3D printed stuff. And medicine, 3D printing a medicine is also a big research area, and I would expect that quite soon we have 3D printed medicines available in the hospitals or pharmaceutical businesses, and many, many more. So the overview here is that this is not about the lack of materials. We have the materials for all needs you can imagine. And if the material doesn't exist today, it's quite straightforward to take the requirements on the table and develop the materials for that specific needs. In this picture, there are 4 examples of these materials. Top left, you can see a serial production with aluminum products. On that picture, you can see 120 components printed in one run with metal. The top right picture is a bridge. It's a 3D printed with a robot from wood composite. And the fancy thing here is that it's perfect copy of a natural birch leaf from the forest. So it's perfect one-to-one copy of the birch leaf. That's what we call biomimicry. On the bottom left, you can see a kidney, which is printed with full color printing, and on the green dot there is actually a tumor, and this whole kidney is printed straight from the patient data that comes from the CT scan from the whole hospital. And the bottom right, you can see examples of different colors. Color palettes can be used in different materials. So this is about the materials. Some time ago, we did a study that is there some area of life or business where 3D printing is not yet used commercially? And the result is that there is no area such, i.e. 3D printing applications are already in all areas you can imagine. And that's, I think, very, very interesting notion. And they are typically used for, many of you may be familiar with the prototypes, visual models, product development. That's one part, but it's kind of getting smaller and smaller part of the whole business. Actual products are done all the time in all the locations, not only products, but production. And now the trend is heavily towards serial production, which we have been also doing since 2016. Spare parts, very popular application, but not only spare parts. The idea of these better parts is that when you have a spare part, it's broken, kind of the part is broken, and you study why it is broken. You can fix that feature and make it better. So when you install the 3D printed better part, it's better than the original. And that's the logic how you can go for new types of improvements in the products. And also very popular thing today is the personalization and customization. Individual products that are perfectly fitted for the purpose. Here in the pictures, you can see some of these applications. Top left is a parametric eco wall, kind of green wall, 3D printed plastic. Top right, you can see kind of this support that you can have if you have any injury or healing the hand. Those can be done to your specific measures. Bottom left, there's a sushi, design sushi, and there's this open meals food singularity business that they really, you can design geometrical sushi parts and have those available in the restaurant. Very fancy area. Bottom right, there's a kind of very high precision part, 3D printed out of copper, some kind of rotator for some system. The point here, if you can find any area where 3D printing is not yet used, just let me know, and I will surprise you and show you the application. A summary or state of the art. Industry level 3D printing technologies, materials, applications, tools, and business cases are available for all business needs. There is no limit anymore. And you can really do very exciting things with this technology. So what is the challenge that we are talking about? The main challenge with 3D printing, it is not the technology. Certainly, it's not the technology. It is our capability to imagine the next generation products. So what are the products that we want to and can create even today, but especially, let's say, next year after that? Trust me, technology is not the limiting factor anymore. The sad thing here is that how many of us can imagine things that have never existed before? And the number is less than 1%. So the audience of this webinar, if we look at statistics, there may be one person who can imagine things that really have never existed before, but the rest of us can't. Mostly we are copying something that we have seen before, we have read before, we are improving something, but I mean truly new solutions. And that is the real challenge that we have. Now I'm going to show an excerpt of the movie Apollo 13. I think quite many of you are familiar with the Apollo 13, and the story goes so that there was an attempt to go to the moon with the rocket, but when the journey had gone for some time, there was serious problem on the rocket, and they had to solve the problem. I will show this about, I think, a little bit less than 2-minute video, and after that we will discuss that a little bit. Quiet down. Quiet down. Let's stay cool. Procedures, I need another computer up in the RTCC. I want everybody to your support teams. Wake up anybody you need, get them in here. Work the problem, people. Let's not make things worse by guessing. We're seeing the same 13. Can we side of this from a standpoint of status? What have we got on the spacecraft? I'll get back to you. Gene, I'm wondering what the Grumman guys think about this. We don't make any guarantees. We designed the LEM to land on the moon, not fire the up there for course correction. Well, unfortunately, we're not landing on the moon. I don't care what anything was designed to do. I care about what it can. We are in the same situation as with Apollo 13. We are developing the products and we are solving today's problems in our product development. We are finding improvements. But is that the real problem that we should be solving when if we want to compete in the future? 3D printing can be used for solving today's problems, of course. But more than that, it can do much more. So we can take the attitude from this leader of this mission, take the attitude and think that I don't care what anything was designed to do. I care what it can do. So what 3D printing can do? Can we change some of the vision we have and really count and bet on the capabilities of 3D printing? I'm not talking about some slight improvement on our processes, but I'm talking about what is the future, what is the best we can do with this emerging and very well mature technology. I recommend this movie, by the way, to anybody who wants to do problem solving. We have an imagination challenge in 3D printing. It's not technical challenge. This challenge asks what are the new features and new functions we want to create? What are the new designs we can have in our systems, products, components, and what are the new product strategies? The strategies may be fully different that we have in the past because the business logic, business models can be totally upside down compared to what we have today. What are the overall new solutions that we can create? And how we learn the new ways of thinking and designing. These kind of challenges we have, and those are the most interesting challenges, at least to me. And here's an example. Here's a hydraulic block from our customer. Its weight is like more than 3 kilograms. It has 33 individual components, all these small nuts and bolts and everything. These guys came to us and asked that, could you print this component so we can see if this 3D printing is good for anything? Maybe you can improve it a little bit before you print. Okay, we say to these guys, oh no, please go away. We want to think a little bit more before we go for the 3D printing. And if you now imagine how would you improve this product, how it could be better, maybe you can decrease some material, maybe you can do something a little bit smaller, etc. The typical engineer approach starts to optimize features that you can see here. But when we took the 3D printing mindset, now you can see the product that we actually created. This is 3D printed with aluminum. Weight is less than 300 grams. So we went from 3 kilograms to 300 grams, and there's only one component. The functionality is better, the cost is lower, it's easier to install, and so on. And now the question is, could the traditional engineer trained people have been able to imagine this component? I would say no. And this is the step that we must take for the future when we create new products and new solutions. The problem is quite analogical to this situation, whatever is your product or business. So we are talking about the new world of design. These are the examples of the products that we have today on the market. There are heat exchangers like the copper product on the top left. There are different structures, holders, tools that you can really optimize everything you want to optimize and do only the thing that you want. On the top right, you can see wood product, which means that you can simply think wood as a 3D printing material and then think what you would like to do with all the material capabilities and design capabilities, all the green values, and so on. And same goes for the top bottom line. There are spacecraft parts. You can think about art and music instruments or anything that is on the art creative side, or like in interior designs for different types. All this is now what we are talking about. And if you think that these are what we have today, where are we after a couple of years? The development is not stopping on this. So what are the drivers for this kind of thinking? Why this makes sense? Everybody knows very strongly that sustainability is a heavy requirement. And these designs, this approach is more than suitable for sustainable strategies. We need to find more and more systemic solutions. So instead of designing individual components, improving something a little bit, we must always look at the entire system, how to optimize the system. We are working more and more in a connected mode on online. People can be anywhere like we are today. So we are more than hyper connected, and we can create things together. And that's a power. We have global brain that can develop these solutions so easy. And it's so easy to connect more and better people to this development. It would be quite interesting to have an innovation workshop with you guys coming from so many different backgrounds. These new things ask for new competencies. So we will new education, new type of thinking, combining competencies like medical expertise and 3D printing expertise, and create whole new competence descriptions. And then we have very, very nasty problems in our societies, for example, with waste or carbon. And it's obvious that future products can solve our most nasty problems, wicked problems, better than the old products and old solutions. If I had a time machine, I would bring Leonardo da Vinci today here and ask what he would do with 3D printing. I think he would invent quite nice ways to make his dreams come true with 3D printing. Maybe that's a good thinking exercise also for you. What would Leonardo da Vinci do in your case? Okay, now let's look at the opportunities. Let's look at the future. So we are talking about the next generation products. They are vision-led products. They are more and more based on the idea that you have a strong vision of what should happen, what problem we want to solve. That gives you vision, and then you can go for that vision by creating the products. And the next generation products have in common that they are made for the purpose, they are optimized for the purpose, they are made on demand, not for the stock. All the features are optimized, all the design is optimized. There's new design capabilities like organic design or biomimic design. Material used is optimized, is perfected for the circular economy, cost is optimized, and new business models will now emerge. This list gives you an idea of what are the next generation products that we must look for, that we must create for the better world. There is a new generation of designers which think totally differently, and they can use these different technologies as a mode. They simply put together different technologies and shape what is their vision or dream. And here's a video coming. It's about Anouk Wipprecht. She is a Dutch designer, but lives in the USA. And this video tells about one product, actually two products that he has been implementing, not recently, but I think this was a couple of years ago already. So let's listen to Anouk Wipprecht.
My name is Anouk Wipprecht. My background lies in fashion design combined with engineering and fashion design. Technological couture with systems that are flirting with artificial intelligence, projected as host systems on the human body. My designs move, breathe, and react to the environment around them. Very literally. One of my dresses, for example, the spider dress. When you step into the personal space of the wearer, this dress is attacking you, measuring out the different zones that we have around the body. The intimate, the personal, the social, and the public space. As you come closer, the sensors in this design measure your distance, and combined with the respiration sensor built into the dress, the design lunges into an attack mode near, provoking a territorial interaction and threatening you to back. Measuring stress levels is important. I'm interested in wireless biosignals and by the means of, for example, brain heartbeat, lung volume, and more monitoring agents, trying to indicate the stress levels, both caused by the body itself or by measuring what goes on in the wearer's environment that possibly causes stress. I'm interested in automation and robotics that may influence well-being, either in an emotional, psychological, or physical manifestation. The topic of stress and towards developing a wearable that can help us connect with ourselves more. The perspective of my work is that though technology came into our lives to help us, it often ends up overwhelming us instead. Technological couture can create a new wave of interfaces that are not handheld, but communicating with our skin and emotions, amplifying our internal states. Garments came into our lives to protect us and shelter our skin, but fashion has been able to express and communicate, and I would like to steer this more interactively, a new way of interfacing with the world around us.
So this is the way where we are going. We are integrating technologies, finding the synergies between different technologies, molding them together. And this new generation of designers is probably the persons who show us the way to the future. Janne Kyttänen is also one of those guys. He's a Finnish guy, but has been working in Netherlands and in the USA and now in the Netherlands, but he's focusing on the creativity and imagination in 3D printing. And he describes creativity that it's the ability to perceive the world in new ways and find hidden patterns to make connections between seemingly unrelated phenomena. I think it's very well said about how we should be looking for the solutions, not replicating the past, but observing what is now, what is happening, and then find the solutions. What the future products look like. Maybe you start to have some understanding of what could happen, but I made a simple experiment with the AI and asked from the AI what the future products look like. And this is what this AI told me. You can see all kind of shapes, very, very complicated products, maybe features that we haven't imagined yet at all. So our future will look something like this, more or less. In the short term, of course, the change is slow and it may be difficult to find. But when we look at the long term, let's say 10 years' time, this really is the world where we are going. And if you want to go to this world, when you should start? Is it today? Businesses will change because of this that I have been describing. There will be disruptive businesses. There will be outlier businesses that look in the beginning very, very strange, but they will be, some of those will be the winning strategies and winning businesses. For example, Google was a very strange company because they promised to connect all the data in the world. In 1993, 94, everybody was almost laughing to Google because of that. But we don't laugh anymore. The business models can be very strange because the business logic is different and it can be designed to be different. And we will see very new types of value chains that are global, digital manufacturing, digital creativity value chains, not local, not country specific, not in any specific domain. Simon Sinek is a very interesting thinker, and once he drew this kind of picture showing about what we are doing. And in his idea, there's these three layers: what, how, and why. What describes what we are doing. How describes how we are doing it. Why is the question that we mostly don't properly answer why we do it. What is the purpose of the activities? And now when I reflect the things that I have been describing this. How? Yes, we had the technologies. We had the 3D printing technologies to do things. We have other technologies together with 3D printing, and we have the tools. We may know why, but I would say that even now we don't know why we do what we do. But the focus on this presentation, on this webinar, is on this what. What are we doing? And this is the imagination challenge. I would say that we know that we must and can do something very, very different as next generation products, but actually we don't know yet what those are. So the efforts at the moment should go for exploring this what. One of the strange business models in this next video, that is the last video that I'm going to show. It's about Enable, which is a global movement. And the global movement is creating prostheses for the children that don't have hands. And the kind of proper solution is that you have a very well done prosthetic by the medical experts and pay a lot of money for those prostheses. But in this case, this is the opposite. There are volunteer networks creating prostheses for the kids. A prosthesis can cost to the family like 10 euros, $10, something like that. And this video is coming from the Enable, describing how the customer are we able to challenge the past. Now we can imagine a world where 3D printing knows no bounds. Every product is not just tailored, but perfected for the purpose. The materials, designs, and costs are optimized to extreme. This leads us towards a society of hyper-personalized, circular, and cost-efficient, perfect products. Is this the future we desire, or disruptive force we fear? To conclude this presentation, we have a huge opportunity regarding future of our products and solutions. This is an imagination challenge, it's not a technological challenge. And the question is what the businesses should do. Thank you.
Thank you so much for the presentation, Pekka. So we're open for questions now. If you have any questions, just please feel free to type in your questions on the Q&A tab of this platform or on the chat box. We have one question here, Pekka. I will show it on the stage if you can see it.
Can a moving object can be captured through 3D printing? Um, if I understand correctly, it means that a object is moving, and can you capture the shape of the object and then afterward print that? Yes, you can do. It's coming from the video technologies where you can basically do a 3D model with any objects, but to capture a moving object, it's a bit more higher cost technology. Still, standing objects you can capture like with iPhone software.
Okay, thank you. So there's another question here. If you can see it.
Yes. Now, if you look at the cost of the machines, if you look at the most cheapest machines, 3D printers, I think they are like $100 at the moment when you get something that can do something at home. But I don't recommend that for any business use. But these very cheap machines are okay when you learn the ideas and principles of 3D printing. Our manufacturing environment is like 1 million euros per machine. And that's the range from 100 euros to 1 million euros and up to that, depending on what you want to do. Metal products, printing machines are, of course, more expensive than polymer printing machines.
Okay, thank you. Any other questions? Okay. So please feel free to type in your questions on the chat box or on the Q&A tab of this platform. And while we are waiting for other questions, just few reminders. So this webinar is recorded and you can replay this webinar using this platform, which is AirMeet. We will also upload the recording to our YouTube channel. So if you would like to replay it, please feel free to go to our YouTube channel. And we will be sending certificate of participation in the next 7 days for those attendees today. And lastly, if anyone here is not yet a member of International Trade Council, we will be sending you a free membership link. Any other questions? While we are waiting for other questions, I'll give you the time, Pekka, to discuss more, or if you would like to say something else about the presentation, go ahead. We still have 9 minutes.
Thank you. Well, I think this is a theme that I'm super interested to connect and create new ways to collaborate. So I'm very open to all ideas and proposals on what new we could find out together, independently of what is the business model or whatever. But this is about developing new level of ideas with new networks of people. So simply feel free to reach me and we can find out something on this area.
Okay, thank you. So the details or contact information of Pekka is here projected on the screen. So if you would like to reach him directly, please feel free to do so. I don't think we don't have any other questions. I don't see any question here in the chat box and in the Q&A part. So I think we can conclude the presentation for today. Any final words from the attendees, Pekka?
Yes, my final words is that whatever is your business or activity, there the 3D printing will be or is already somehow part of that. So in your teams, in your organization, please support people to study, to explore, to try out 3D printing. develop your capabilities for the future. It doesn't need to be massive investment. It's simply opening up the doors for curiosity for the people who are interested to develop. Let them explore and support them in exploring this exciting field. And that's maybe my best advice at the moment.
Okay, thank you so much. Thank you for your presentation today, and thank you everyone for attending today's presentation. And we look forward seeing you again in our future educational webinar. Thank you for your time, guys, and you all have a wonderful day. Thank you, Pekka.
Thank you. Bye bye.